This is for Year 12 Methods. It's the 2019 Tech Allowed Functions application SAC question number 3. So we have these termite mounds and we're given this particular set of values in this table, logarithmic, 3 decimal places. So I'm going to use the statistics component of the calculator. Time is x, so that's 0.3, 1.46.3, and here is my height. I'm going to do a calc regression logarithmic. I've got my x's in list 1 and my y's in list 2. Okay, and here's my values. A is 2.5738, B is 1.31377, and then I can put it into this form, remembering A plus B log base E of x is told to you at the top of the statistics calculation bar. So there is my rule. Okay, so the second part says the same mound has this termite data where my height is being used to predict the population, and I have to come up with an exponential model. So I've entered these results here. My x is now in list 2 and my y's are in list 3. So if I do calc regression, I'm going to do an exponential regression. My x's are in list 2 and my y's are in list 3. And I go OK. And these are the results that I get, 0.1149, etc., etc. And I'm going to put that into that form. The question is then asking, how many termites would you expect in the mound after 10 years? Well, I need to put 10 where the t is, and then that h value I place in here for the h value. So when I put 10 into here, I get 5.599, and then when I place that into the p-value, this is what I end up with, so 3.894 million termites. If I come down to part D, I'm going to go off into main to do that. So I've got keyboard, pi brackets, 3 r squared plus h squared. I think it's important to use the actual variables. And if you just use x and y all the time, you can get them confused. And that's going to be over 6. And I know that h equals 2. And I also know r equals 30 centimetres, so 0.3. And that gives me that expression, which is what I get. Then I'm asked if the volume is 8 pi, so if I take this and I make that equal to 8 pi, and I'm looking for some values, and if I set h equal to 2, solve for r, then that's one possible value. R is 3.82 meters and h is 2 meters. If I make h equal to 3 meters, then I get these values of r, which are much smaller again. If I make h equal to 6 meters, then r equals 2. If I make h equal to 7 meters, then I don't get a solution because h can't be 7 meters because the height of 7 meters will be too big. So let's say I say 6.926. Then I get these values of r, which is 0.01, 0.1. So lots of possible solutions are acceptable. In this question here, I've got log base E of n is this, get an expression for n, so just turning it straight into an exponential, n equals e to all of that. So I've typed these in, but I've used x instead of using t, and it simplified it into this form the minute I pressed x here, which is why I also accepted this answer. If I'm going to graph this, drag and drop, I'm going to be thinking about termites for different temperatures. So let's say we're out in the desert and we might go up to 60 degrees, and I do zoom auto, then I can see that the maximum amount of I just realized that I mistyped my entry here, so I've redone it. And if I do analysis gsolve max, I end up with a maximum of 38 degrees, and that's 875 million termites. What happens when the temperature is cool? Well, if I look at this and get a y-intercept, I get 0. So when it's very cool, there are very few termites. When it's 38 degrees, I get the maximum number of termites. And as it gets hotter and hotter and hotter, the number of termites reduce.